So today we are going to discuss about trigonometry in non-right angle triangles. Now this thing may sound a little odd because in the beginning when you start trigonometry we all talked about trigonometry is all about right angle triangles. But there are just few cases where trigonometry is applied for non-right angle triangles also. So let's discuss those things. So let's first draw a triangle. Let's say but this is almost beginning to look like a right angle triangle again. Okay, let's put it this way. So let's say this is our triangle and this is A, B, C. So the sides are A, B, C. So there is something called law of sines, which is sines meaning sine of theta or sine of x. So the law of sine is sine A by A, which means the angle A by the side A equals to sine of B by B equal to sine of C by C. So let's take an example and then let's explain how we can use this formula to solve something. So let's choose a different color. So let's say we have an triangle which has, let's say this is 35 degree, this is probably 45 degree, and this is 100 degree. So that makes it 180. So, and let's say we have this one as 8. So we have to find out the length of A and C. So if you apply this formula, sine of B, which is sine of, okay, so let's say sine of A, which is 100 divided by A equal to sine of B, which is 45 by B is 8. So from here A equal to sine 100, if you get, is around 0.98. So first let's write A equal to sine 100 divided by sine 45 times 8, which is sine 100 is around 0.98 divided by sine 45, which is 0.7. 7 times 0.8. So you can solve this and get the value of A. And then the same way you can put sine C, which is sine 35 by C. So again, using these two, you can find the value of C, just like the way we have found the value of A using this and this. So this is one way you can use this formula to find the length of sides when the angles are given. So this is the law of cosines, which is sine of A divided by sine of B by B equal to sine of C by C. The way to remember is that it's the angle with the opposite side. So angle A with the opposite side, which is A. So this is the ratio. Now there is also a law of cosines. So let me first clear the board here. So we're talking about law of cosines. So let's first write law of cosines. So for law of cosines is, again, let's first draw the triangle. Again, this is again a law not on a right angle triangle. I mean, you can make it also work for right angle triangle, but this law is applied to any triangle. Now for a right angle triangle also this is valid. But basically this is a law which you can apply on any triangle. So let's put the numbers A, B, C, and this is C, this is A, this is B. So the law is C square equal to A square plus B square minus 2AB cosine C. So let's look at it carefully. So C is this one equal to A square plus B square minus 2AB of the angle made by them. So you can put the same formula with respect to B, where B square equal to C square plus A square minus 2AB. So if you look at the formula, as I was telling you, this is applied only to or this is applied to any triangle. Now if you think the right angle triangle really is a generic, if you apply right angle triangle where C is a right angle, so C, if C becomes 90 degree, so then C square equal to A square plus B square minus 2AB, and cosine of 90 degree is cosine of 90. Now cosine of 90, as you know, it is 0. So A square plus B square. Now if you look at carefully, C square, it almost looks like Pythagorean theorem. And that's what it is. If C becomes 90 degree, this triangle would look totally different. It would look something like this, or not exact. Let's say this is 90 degree. Yeah, so this is 90 degree. So then the other two sides, C equal to B and A. So again, using this formula you can solve problems where you are given, let's say you are given two sides. So let's draw a triangle. Let's say you're given this and you're given one angle, and you are given the sides. Let's say this is 10, this is, or maybe this is 5, this is 6. So you're given this, and you have to find out length of this. So in this particular case you can apply the law of cosines, because you know two, so the law to, so this law would be applied when you know two sides, two adjacent sides, and the angle within them. So using that you can find out the remaining side. So I think that's the other two laws which is in the trigonometry, but most of the times you will be using the other rules which you have learned before, which are associated with sine theta and sine theta, cos theta, and on right angle triangles. So just to recap on the trigonometry, all the things we have learned about one formula where we say sine theta equal to adjacent side by over or the opposite side over hypotenuse, which is so ka toa. I hope you remember what it is. So it is about relations among sides of a right angle triangle. Then we read about sine square theta plus cos square theta equal to 1. Then we read about other things like inverse of sine, cosine, and tangent, which is cosecant theta, which is C. Then we secant and cotangent. So we read about this. We also read about sine theta by cos theta equal to tan theta. So that's all. Hopefully you got a good review of trigonometry.